Friends, welcome to our channel. Let's have a look at problem 36, 38, maximum balanced shipments. In this video, we are going to solve this problem using the idea of monotonic stack. This problem actually gives an integer array called weights of length m. So a shipment is defined as a contiguous subarray of parcels. A shipment is considered balanced if the weight of the last parcel is strictly less than the maximum weight among all parcels in that shipment, right? Because there's an order, right? And also there's a comparison between the weights. So we want to select a set of non-overlapping contiguous balanced shipments such that each parcel appears in at most one shipment, right? This corresponds to a partition of the subarray, of the original array. So we want to find the maximum possible number of balanced shipments that can be formed. So actually this requirement, we want to find the maximum possible number of balanced shipments, simplifies the problem, right? So here, if you look at the examples, example 2 is an example that cannot form a balanced shipment, so the output is 0. So in example 1, actually, so you have 2, you have 5, so this is increasing. You cannot form a balanced shipment. But once we find a smaller one, this one, as long as it's smaller than the previous max, for example, here is 5, but it's actually also less than 2. If there were no 5 here, 2, 1 still a balanced one, right? So 2, 5, 1 forms a balanced shipment. And then you continue with 4, right? And then 3 is less than 4. Immediately it forms a valid one. So because of the maximum, right? So the count, we just need to find the count in this problem, right? So this 2 finds the maximum possible number. It's because of the maximum and because of count, it greatly simplifies the problem. So here, this is the constraint. It's about the problem size, right? So if you have practiced quite a lot on monotonic stack, so this problem should be rather straightforward. So if not, you can visit our playlist to practice some problems with monotonic stack. So in this video here, we are going to maintain a local monotonic increasing stack, like here, right? So notice that in the stack, we are going to store indices, not numbers, right? So the idea is rather straightforward. Actually, it's like a gradient way. So when we meet a parcel which is less than the top element in the stack, because we are going to maintain a local monotonic increasing stack, that's why we can just check the top element. So we form a balanced shipment. I will say here. So now let's look at the coding, and then we can, after the coding, we can do some prints. That way you will get the details. So I'm going to initialize a result. So it's an integer, right? So we want to return its final state. So also we have a stack. So then basically we want to do a linear scan of this weights. So I changed the function to be w just for the convenience of writing. So here also I want to track the number and the index. So for IY in enumerate, right? This w. And then what we are going to do is first, if we have the stack is not empty, add the top element at the stack, that is stack -1. Because we have first checked the stack, then the condition after add is a valid one. If this weight is larger than the y, immediately we formed with the current indices, the corresponding elements in the w and the current y, we form a valid shipment. So though the element might contain maybe possible other elements, but the count is we just need to increment the count. I hope you notice this point, right? So here we are going to increment the result by 1. So in this case, immediately I'm going to reset the stack. So this reset of the state is very important. It's for the total counting. So this is the one. Otherwise, the two cases. Either when we look at the current weight, so the stack is empty, or the stack corresponding to a not a larger parcel, we need to continue, right? So in this case, so while stack and w stack -1 is less than the current one, right? So we just pop up, right? So then afterwards, so we are going to append the current index, right? So this will be our full logic. So actually, up to now, you can do the return the result, right? So you can check it passes the 2 test cases. So now let's look at the generic case. Yeah, it passes the generic case first. So now let me print out some information so that you know what we have. So first is stack when entering this step, I step. So let's see, the stack is like this. So also let's add here and print a. So here is after. So it should be exit. So now let's take a look. So f string involves syntax. That's the f. So here, yeah, I guess I should have this, right? Something here. So if you look at this first one, right? So at this index 2, you can form 1. So after index 2, so I reset that, right? So let's also, I guess we should also monitor the result, right? So, after exiting the index 2, step we have result is 1. After 4, you get another increment. So if you look at 2, right? So the stack is 0 and stack is 1, but the result is still 0. So with that said, I guess that's basically about it for the current video. You're welcome to practice some more problems using the monotonic stack playlist in our channel. Thank you for watching.